Lesson 8, Biconditional Statements and Definitions. Your learning target for this lesson is to write and analyze biconditional statements. The vocabulary, or biconditional statement, definition, polygon, triangle, and quadrilateral. A biconditional statement is a statement that can be written in the form P if and only if Q. This means if P then Q and if Q then P. A biconditional statement is created by combining a conditional and its converse. The notation, we use P, IFFQ, or P with a double arrow in Q. IFF is not a misspelling. It means if and only if. P with a double arrow pointing to Q means P implies Q and Q implies P. Let's try an example. Write the conditional statement and converse within the biconditional. An angle is obtuse if and only if its measure is greater than 90 degrees and less than 180. It's fairly easy to figure out which part is the beginning, or our P, because it comes before if and only if. If and only if breaks the two pieces apart. So let's let P and Q represent the following. P is an obtuse angle. Q is an angle's measure is greater than 90 degrees and less than 180 degrees. The two parts of the biconditional, P if and only if Q, are P implies Q and Q implies P. So the conditional will be, if an angle is obtuse, then its measure is greater than 90 degrees and less than 180 degrees. The converse will be, if an angle's measure is greater than 90 degrees and less than 180 degrees, then it is obtuse. Let's try another one. Write the conditional statement and converse within the biconditional. A solution is neutral if and only if its pH is 7. Let X and Y represent the following. X will be a solution is neutral, and Y will be a solution's pH is 7. The two parts of the biconditional are X if and only if Y, and you have X implies Y and Y implies X. The conditional, if the solution is neutral, then its pH is 7. The converse will be, if a solution's pH is 7, then it is neutral. You give it a try. Write the conditional statement and the converse within the biconditional. You might want to pause your recorder while you work this out. An angle is acute if and only if its measure is greater than 0 degrees and less than 90 degrees. Let X and Y represent the following. You should have said that X is an acute angle. Angle is acute. And Y will be an angle has a measure that is greater than 0 and less than 90. The two parts are X implies Y and Y implies X. So your conditional should have been, if an angle is acute, then its measure is greater than 0 and less than 90 degrees. The converse would be, if an angle's measure is greater than 0 degrees and less than 90 degrees, then the angle is acute. For each conditional, write the converse and a biconditional statement. So in this case, we're given a conditional statement already, and we need to write the other two parts. Remember that a converse is so that we take P and Q and we just swap them. So if 5x minus 8 is 37, then x is 9. The converse would be, if x equals 9, then 5x minus 8 is 37. The biconditional, we go back to the original statement, the conditional, and we say 5x minus 8 is 37 if and only if x equals 9. Let's look at B. If two angles have the same measure, then they are congruent. The converse, if two angles are congruent, then they have the same measure. We go back to the original statement for the biconditional, and we say two angles have the same measure if and only if they are congruent. You give it a try. If the date is July 4th, then it is Independence Day. You should write the converse as, if it is Independence Day, then the date is July 4th. Going back to the original statement, you write the biconditional as, if it is July 4th, if and only if it is Independence Day. The truth values of biconditionals are very important because they are the same every time. In order for a biconditional statement to be true, both the conditional statement and its converse have to be true. If either one is false, the entire statement is false. Let's try one. Determine the biconditional truth value. If it's false, give a counterexample. Remember, a counterexample is only one example that proves that one side or the other is false. A rectangle has side lengths of 12 centimeters and 25 centimeters if and only if its area is 300 centimeters squared. Well, let's look at the conditional statement and see if it's true. The conditional statement would be, if a rectangle has side lengths of 12 centimeters and 25 centimeters, then its area is 300 centimeters squared. Since area is length times width and 12 times 25 is 300, this is true. The converse would be, if a rectangle's area is 300 centimeters squared, then it has side lengths of 12 centimeters and 25 centimeters. Well, I could break other factors of 300, couldn't I? Can I find a rectangle that has 10 and 30? Or one that has 2 and 150? Those are two counterexamples, which means that the converse is false. And we said before, if one is true and the other is false, the entire statement is false. Let's try another one. A natural number n is odd if and only if n squared is odd. Well, first we want to go ahead and write the conditional statement. If a natural number n is odd, then n squared is odd. Well, let's think about that for a minute. A natural number n that's odd, well, that would be 1, and 1 squared is 1. 3 squared is 9. 7 squared is 49. Yes, they all seem to be odd numbers. This is true. Let's look at the converse. If the n squared of a natural number is odd, then n is odd. Well, how could we test that? Let's think. To get n from a square, we would take the square root. So if we take the square root of odd numbers, like 81, that gives us 9. or 49 gives us 7. Yes, we get an odd number when we take the square root of an odd number. So the converse is true. That means that since both are true, the whole statement is true. You give it a try. Determine if the biconditional is true, and if it is false, give a counterexample. You might want to pause the recording to answer this. The statement is y equals -5 if and only if y squared is 25. The conditional statement would be if y equals -5, then y squared is 25. Well, that's true. If y is -5, -5 times -5 gives me positive 25. This is true. The converse would be y squared equals 25, then y equals -5. Well, isn't 5 squared also 25? So it doesn't have to be -5. That means that the converse is false. And you should have said that the biconditional is false because when y is 5, y squared is also 25. In geometry, biconditional statements are used to write definitions. A definition is a statement that describes a mathematical object and can be written as a true biconditional. Some other definitions are: a polygon is defined as a closed plane figure formed by 3 or more segments. The figures on the left are polygons. You notice they have no lines crossing on the inside, and they have no open edges or rounded edges. They are line segments. The figures on the right are not polygons because they have either rounded edges, lines that extend past the figure, opened edges, lines that cross the figure, or they are three-dimensional. Triangles and quadrilaterals are polygons. A triangle is a 3-sided polygon. A quadrilateral is a 4-sided polygon. And here are some examples. Think of definitions as being reversible. They make good biconditional statements. Postulates that we've seen earlier are not necessarily true when reversed. Let's write each definition as a biconditional. A pentagon is a 5-sided polygon. How about a figure is a pentagon if and only if it is a 5-sided polygon? Let's look at the second one. A right angle measures 90 degrees. How about an angle is a right angle if and only if it measures 90 degrees? Now you try. Write each definition as a biconditional. Go ahead and pause so that you can get this taken care of and come back and see if you were right. 4a says a quadrilateral is a 4-sided polygon. The biconditional would be a figure is a quadrilateral if and only if it is a 4-sided polygon. 4b states the measure of a straight angle is 180 degrees. The biconditional would be an angle is a straight angle if and only if its measure is 180 degrees. Please complete the graphic and place it in your folder for next class. During the next class, we will have bell work, truth tables review, an activity if and only if it were true, and a lesson quiz. I'll see you then.